Hello, welcome back. We're going to be simplifying radicals that involve multiplication and division. This is part 2. Two things are going to happen in this lesson compared to the last lesson. The first thing is that we're going to be dealing with square roots, but also we're going to be dealing a lot with cube roots. So we're going to be increasing the complexity by increasing the root order that we're dealing with. The second thing is we're going to have larger numbers that we're going to be dealing with, and we're also going to be dealing with more properties that we need to use. So we learned about the properties of multiplying and dividing radicals, also the properties of when you have a radical raised to an exponent, things like that. We'll be incorporating into these problems. The good news is if you understand the properties of radicals, none of these problems are hard, but I am going to work a couple of different ways to show you that you can get to the answer by different avenues. All right, so let's just crawl before we can walk. What if we have a pretty easy problem? Let's say that we have 250, and we're not going to take the square root of it, we're going to take the cube root of it. That's what that means. And so what we need to do when we solve a problem like that is try to do a factor tree, right? Now we know 250 can be written as 25 times 10. And we know that 25 can be written as 5 times 5, 5 times 5, and 10 can be written as 5 times 2. So because this is a cube root, we're not looking for pairs, we're actually looking for triplets of numbers in the factor tree. So this is a triplet of 5s. But again, it only counts one time, so when we pull it out, a single 5 comes out. The 2 stays under the radical, but it's not a square root. It has to match what we started with, so it's a cube root. Now be really careful when you write your answers, okay? I've done this a lot myself. When you have something like 5 times the cube root of 2, it looks like 5 cubed and then some radical here. So to kind of not confuse yourself, put a little dot between them. This means 5 times the cube root of whatever is under there, because that's different than if you accidentally put that exponent on the 5. So that's the final answer. Just a warm-up problem dealing with cube roots. Now let's get into the real meat of the matter. Let's say we have the fraction 5/4, and we're going to take the cube root of that. How do we do that? Well, we can't really simplify 5/4. We can't really do a factor tree. So what we need to do is break this. We have a fraction under a radical. We can break it up into a cube root of 5 on the top and the cube root of 4 on the bottom. Notice we have a cube root initially. So the daughter cube roots, for lack of a better word, they have to be cube roots. They can't be square roots. They have to have the same order of what you started with. So just like you can combine these and go this way, you can break them up going that way. All right, so the next thing you're going to try to do is see if you can actually simplify this. Like, is there any way you can actually take the cube root of 5? Well, you go here and you say, well, that's 1 times 5. There's no triplets there. I can't do anything with it. You take the 4, because you think, oh, square root of 4 is easy. What's the cube root of 4? Well, we have 2 times 2 is equal to 4, but I need a triplet here for a cube root. So I actually cannot simplify the numerator or the denominator. I can't do either one of those things. So what I want to do is simplify it, right? And I have a problem because one of the things we don't want is we don't want any radicals in the denominator. So if I try to simplify this, if I try to circle this, you're going to get it wrong because you don't want to have a radical here. That means you don't want to have a square root, you don't want to have a cube root, you don't want to have 4, you don't want to have any radicals in the bottom. So you have to do what we called in the last lesson, rationalizing the denominator. So let's go down memory lane really quickly since this is a new lesson. Remember, let's just pretend the cube roots weren't here. Let's just say, because there's actually going to turn out to be a trick here for rationalizing this. So for the time being, put this on hold. Let's pretend that our problem was square root of 5, square root of 4. A little bit different. How would we get rid of this? In the last lesson, we learned that we just multiply by whatever's on the bottom. Square root of 4 divided by square root of 4, because what we're doing is multiplying by the number 1. But we're just writing the number 1 as root 4 over root 4. So what happens is, on the top, you're going to get the square root of 20, because 5 times 4 is 20. And on the bottom, you're going to get 4 times 4. We all know that's 16, but I'm going to write it like this. I'm going to write it as 4 squared. Yes, I know that you know that's 16, and you know that the square root of 16 is 4. But I like writing it like this because then you'll have square root of 20 on the top, and the way I want you to think about it is the square root kind of cancels with the square function there, leaving a 4 behind. So by multiplying by what we had on the denominator with this radical, no matter what is underneath it, you're always going to get a perfect square. You're always going to kill the square root, so you're always going to get rid of the square roots in the bottom. That works perfectly well for square roots. It works beautifully for square roots. Unfortunately, if you have a cube root in the denominator, or a 4th root, or a 5th root, then you have to very slightly modify what you do.